All right, welcome to the tutorial, the tutorial morning for the 2019 Blue Water Symposium. I imagine this will be the last morning, last time we do this in this form. But we have a series of sort of tutorials. This is the first one. I'm going to talk about data management and best practices for data movement. This is going to be very broad strokes. There will be some things that apply specifically to Blue Waters, but a lot of the stuff will be kind of a general how to and things to watch out for on other systems too. So, and I also have a bunch of question slides that are sort of good questions to ask yourself and to ask your other researchers as you move forward in your career. So, as on many systems, the first place you want to look if you have questions or if you need to do something is on our portal. And the user guide on our portal, you go to the portal, you mouse over the Using Blue Waters, you click on the user guide, and then that brings you to the user portal page, and there's an index down the left side, and that'll tell you what the broad categories are of things that we directly cover. And I think this is certainly true in TAC and other places as well as us. I mean, there's a certain amount of sort of banging your head against something, but don't leave it past a day. I mean, if you're stuck after a day of being stuck on the same thing, put in a ticket and say, hey, where's the documentation for this? Or can you help me over the next step or whatever? It will save everybody time, and then and it's a good thing. And then they can point you to documentation that you didn't know was there, and then you know where it is. So then that's an improvement for you. So broadly what I'm going to talk about data management on Blue Waters. I'm going to talk about where the data lives on Blue Waters, which is something that broadly applies to many other systems. We're going to talk about Lustre file systems and nearline tape file systems. Then how to get your data onto it and off of the big system. Just a very, very brief thing about running jobs. Talking about archiving data to nearline. Hopefully you won't be doing that much on Blue Waters, but you'll be doing it on other systems. Retrieving data from nearline, deleting things off of nearline when you get there, and then sort of your final push to get data off of Blue Waters to your next destination. I have interspersed some question slides. These are questions that are good things to do when you start and good things to do when you revisit. Dan Stanzione talked about a situation where, graduate student had inherited code several generations old and had a checkpoint frequency that was probably 1,000 times too high. Those are the sorts of things you want to sort of, if you either scale up or you go to a faster system or you change parameters, it's one of those things you should kind of recheck to make sure that everything makes sense. So the players, here's where the broad outline of Blue Waters, you have login nodes which don't store data. We have this big import-export mover nodes, which are mostly invisible to you, but they help you move data fast and efficiently. Where the data actually lives is on our online mounted file systems, which are Lustre. The nearline systems, which are long-term tape. Data will go back and forth to compute nodes, and then a lot of our import-export will be to and from the outside world, which I've just represented as a cloud. While you're on Blue Waters, this is your data topology, data in through the IE movers to Scratch, back and forth to compute nodes, and back and forth to tape. And then as you're leaving Blue Waters, then you will reverse this data flow, and you'll be concentrating on moving stuff off. By the way, if you have questions, please go ahead and raise your hand and interrupt me. I can, if it becomes a deep and complicated answer, that's fine. We can just write it down, and I can either answer it at the end, or we can talk after the talk is done. So feel free to raise your hand and stop me. So where data lives, there's two main systems, online Lustre disk. These are mounted, so these look like file systems. They are different file systems. They are mounted on everything you care about, on the login nodes, on the mom nodes, on the compute nodes, and they're accessible via Globus. You have your home directory, you have your projects directory, which you share with other members of your allocation, and then Scratch, which is allocated by person. Nearline are tape volumes. Those are accessible only by Globus to you. And you have sort of a kind of a quasi-home directory, which you can just sort of stick personal stuff, but mostly you put stuff in projects. And so there's a home here, a project here, projects here. They're not the same. They are distinct. They are both the underlying file systems and the instance are both separate and distinct. So Lustre, if you don't know about it, you will learn to love it or not, I guess. But Lustre is all the file systems on Blue Waters are Lustre. Sounds like all the file systems on Frontera are Lustre. So this is the thing to know. Every file has a stripe count. Striping control is manual, and it's something that you will have to push the buttons for, and you are responsible for. And it doesn't make flashing lights, but you have to know, and it will cause you performance problems and other people pain if you don't. Lustre striping is a complicated topic, but very basically, every file has a stripe count, and the file system is this giant raft of what are called OSTs. ST is storage target. And so if you have a stripe 1 file, all the blocks of that file will go in one OST. If you have a stripe count 2 file, it will round robin between those stripes. So a bigger stripe count means it's spread across more resources, which may be of advantage to you. How do you set stripe count? There's a set of commands, LFS set stripe. These will be things you will learn to use. You can set a file before you create it, and I will get to that in a second. Or you can set the stripe to a directory, and then any files created in that directory will have that stripe count. Some general striping rules, and this is one, I admit, one deficiency in our notable deficiency in the Blue Waters portal and our documentation. We do not have a detailed explanation or guide for striping. The reasons for that are annoying and complicated, but we just, and so here are a couple of very basic rules. Blue Water specific, at least one stripe per 10 or 100 gigabytes of the eventual file size. Because if you don't do that, then if you just do this, then if you create a terabyte file, all of the blocks of the file will go in one OST. It will fill the OST up, and then everyone will be sad. So you want to avoid that. So you need to kind of know how big your files are going to be and stripe them accordingly. Remember, file size stripe count is fixed upon creation of the file, and it does not change. You also want to stripe according to your access patterns of your code, which is something that you'll need to know about, and I will mention that later. With all of that, pick the smallest stripe count that makes sense. So there's no point in striping your files, your 1 megabyte files 160 wide. That doesn't actually help you. So any questions? Let's see. Stripe count inheritance. So like I said, a file stripe count is permanent once the file is created. It's set at creation time. You can pre-touch a file to set its stripe count, I think. If you move a file, if you MV a file to another file, you can't fix the stripe count that way. The only way to change it is to copy it to a new file with the new characteristics. So, good questions to ask yourself. How big are my files? That is going to drive your striping decisions. How many ranks will be writing to my output files? That will drive the striping decisions for that directory. Can I be clever? Answer is hopefully yes. Can I be clever about where I put my files to make my life easier for striping? So if I have a ton of small files and a couple of really big files, if you create 2 different directories for them, you can just set the stripe counts for those directories, and then all the files will just follow suit, and everything will be happier. Okay, so striping is a really big, important topic, has been on Blue Waters, will continue to be on Blue Waters, is on Frontera. Anyone want to ask questions or talk about file striping on Lustre? Okay, all right. If you're moving stuff to nearline, this is something that mostly, hopefully, you won't be doing a whole lot of on Blue Waters anymore because we're sort of getting into the mode of let's get everything off. But talking about tape file systems in general, there is a file system that lays on top of them that acts like a Unix file system. However, so you copy files and directories and everything on and off. However, if you stick tons of tiny files, the tape system is perfectly happy to spread them thinly over several hundred tapes. Retrieval, and so ingest is very fast because it just dumps onto the disk cache. Retrieval is difficult or possibly impossible because you have to spin hundreds of tapes to get all your files back. And it makes Jim sad. It makes Jim sigh. sigh heavily. So this is just sort of so when you're doing this, when you're using Globus to use the IE movers to move stuff between online and nearline, even though they have similar looking file systems, the granularity is super important. Okay, this is sort of repeat. Lots of fragmentation, very many files are going to cause you problems for retrieval. So package things before moving to nearline. And if possible, any file movement that you're doing for nearline files, just moving them offsite to their eventual destination is good. And just I'll stress this. Brett talked about it a bunch yesterday, but I'll stress it again. Deleting files off of nearline as soon as you are done with them and as soon as you know you will not use them is super helpful to us. It is super helpful to you. It lets us clean up the tape file system. So it's always good. If you definitely know you're not going to use anything, definitely let us know. If it's complicated for using the file system, tell us what the file pattern is and say, this file pattern with this wildcard, I definitely will never need those. And our storage people can just set through a thing that will delete all of those for you. You can package things. I'll talk about this later, but giant, really big, long-running tars on the login nodes will be killed. So you probably want to just fire off a quick job script like this. That's just your usual PBS preamble, and then just an app run tar CVF, and then stick the stuff in a tar file. Group your files up in a reasonable size before you stick them onto tape, or even before you move them across the network. Okay, so any questions about file granularity or tarring or grouping files together? Why we care, how we do it? Do you have a question? Okay. All right. So now how you actually move data in and out. We use Globus. It is good in many respects. It is asynchronous. It will kind of do its thing while you're off, not in your office and exhibiting good work-life balance. It runs in parallel. It has lots of resources. It sort of gears up and uses lots of network resources, lots of disk resources. It'll do auto retries up until multiple days of timeout. However, there's no active error mechanism, or there's an active error mechanism, but the alerting system it's gotten better, but the alerting system is not ideal. So you have to actually kind of pay attention to it. And actually read what it is. So like Globus will, any Globus transfer will have a burst of, I can't get to the network, I can't get to the network, I can't get to the network, and then all of a sudden it can get to the network and everything is fine. Or at the same level of granularity, it will say, the file, the directory you're writing to doesn't exist. And one is not more prominent than the other. So you kind of have to look and check and check things. The other thing is access credentials sort of time out, because the access is driven by the endpoints. And so that's only for a fixed window of time. So it'll email you and say, hey, your access credentials have expired, and you have to actually respond to that. So it's a really good idea if you've got a lot of transfers going to kind of look at it every day or two, glance down, because usually it's a bunch of error reports about there were transits in the network. Look at the average transfer rate. If the average transfer rate seems to be something sane, it's probably generally okay. If the average transfer rate is a hard 0.0, there's probably something genuinely wrong and you need to actually look. But Globus is not very good about, so Globus is great about doing stuff in the background. It's not good about telling you about critical failures. So I don't know if 64 files at a time is the right number. Oh, Jim is nodding, excellent. So, but this is a very discrete thing. So if you tell it to pull 10,000 files, it will queue up the first 64 and then go through all the rigmarole of setting up the long-term transfer and setting up the buffers and setting up the disk caches and everything, and then the data's gone, and then it tears down that transfer, and then it rolls around to the next one. So if you're transferring tons and tons of files, this is another reason to tar them up, because then Globus can sort of open up the pipe and then turn the crank, and your general throughput will be much, much, much higher, which is that's what I just said. Right, okay. So data ingest. So the reason that this all works really well is because Globus is this outside entity, and Globus knows how to talk to these 64 IE mover nodes whose only job, whose only responsibility is to move your data. So you fire up Globus transfers, and there's this really big infrastructure that all it does is move your stuff. And so that all happens in the background, and so that's why it works so well. So for data transfers, if you're about to do a transfer or you're doing a transfer, questions to ask yourself, how is my data grouped now? And we understand this is not necessarily driven by you. You're trying to implement a workflow possibly using someone else's code. So you may not know the answers to these questions, but these are the sorts of things that you ask yourself to sort of say, how can I make my workflow make sense on the machine that I'm on or on the machine I'm going to? How big are my files? What file size range, or what is the file size range that is reasonable on the machine that I'm on? Do these match? What file size range is reasonable at its destination? Carolyn told us yesterday about a thing where we were that on our machine that 100 gigabyte files are great, and then she was moving stuff to places, some of her files to a destination in Europe, and they couldn't take anything more than 10 gigabytes. And so now she's going to have, so asking these questions before you start is a really super useful, important thing to do. And what file size range will transfer more quickly? That's mostly bigger is better, but that's not absolutely universally true. I know there was a point where bigger was better, but anything over 2 terabytes would not fit in cache and would require a tape drive to be mounted on both ends at the same time, and all of a sudden that was horribly slow. And it took us a while to figure out why that was. So the answers for blue waters to some of these questions, are my files less than 10 gigabytes? Do I have more than 1,000 files to transfer? If either of yes, then maybe do some regrouping before you do a transfer. So this is basically cribbed from Brett's presentation yesterday. We have a transfer page that talks about just this in great detail. There's the data transfer page on our portal. It talks about, so Globus you control with a couple of different ways. The Globus GUI, graphical user interface, mouse over using blue waters, go down to data, and then click on the Globus Online button. And it gives you, this is a recent screenshot. They have changed the way that it looks, but here it is. And you basically use it like a drag and drop folder, and you say, all right, now transfer these files. It's pretty easy to use. Whoops. If you go farther down that page, there is a section on the Globus Python-based command line interface. And this is it looks a little bit like this. It's a little bit heavy in sort of setup and stuff, but then it will allow you to use this Globus blah 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 command. You have to kind of use these big ugly strings to refer to endpoints. But it will allow you to do things like ls and see what a directory is inside of the nearline file system, even though it's not mounted. And so this here is Globus's page on it, and we have these partial examples are all taken from that data transfer page on our portal. Galen and Roland are working on a wrapper class wrapper helper class for that API. That do not hold us to any of this because this was sort of constructed at the very last minute. But this is not quite out, but it will appear here on get.ncsa once it's available. It will be in the portal once it's available, and it will look sort of like this. But it will be, you basically, you set things up, you get into IPython, and then you can use this class to do, and if you tab, it'll tell you the list of function completions. You can bring up the key, and then you can do hlp.ls, and then something. Is that approximately within 10% of being true? Okay, nodding heads, good. So,
You may want to explain why we're
wrapping it?
why we're doing this is because the Globus CLI mounts Python every time it doesn't.
Right. So this will, this saves the latency, I guess. Using this method if you use it within this IPython and this class, you load up the IPython class, and once you're in it, you don't have to reinitiate the authentication every single time you type a command. And so it will work faster and more efficiently. Is that right? Okay. So anyway, this will be a way to do it that is, I mean, the Globus API is okay, but this will save a lot of latency. It'll make it work better.
The Globus CLI, the Globus API is so what we're trying to say is the Globus CLI that Globus puts out is not written in such a way that it can handle more than one command at a time. So every time you type Globus, it has to reload Python, reload the Globus module, and then execute the command, and then it exits back out again. So it's a very, instead of having an interpreter prompt and type the separate commands as you go along.
Right. So using it this way, every time you type Globus blah 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 blah, it is firing up a whole Python instance, doing the one thing you told it to do, and then breaking down that Python instance.
Right, the modules and everything. So it saves over, even from your laptop, it's faster. You don't have to run any of these things from Blue Waters. You can run them on your laptop, for example. But we found that what Globus put together, while functional, is not performance. It's really
right. So you do this, then once you're in the IPython thing, then it stacks it up once, and then you can do ls and cp and remove and da-da-da-da-da, all within this environment, and then when you're done, you just exit out. Yes, Roland?
Since this is now all Python, you actually get back Python objects. So if you do ls, if you do a list in Python, you can do something. If you leave something with a Python object, you can create a CP. You don't have to parse it and every day decide if it's a proper algorithm with ls command. It's being readable and parse it out. If you want to just that the actual underlying API that they have, usually in the freelance we are about 150 Python.
So, okay, any questions about that? Okay. All right. For using Globus, this is an editorial point about using Globus. You have a Globus account even if you don't sort of realize that you have it. You have to create it once. You will then typically link with that Globus account. You will link an organizational ID. So like I have one from Blue Waters, I have one from Exceed that are separate. That will allow you to authenticate those endpoints. From then, you can, once you link in an account, you can just use that linked account to get into your Globus account. The reason that this is occasionally important is because if you have to get back into your Globus account itself to like modify some of its fundamental parameters, you cannot authenticate using your linked account. You have to use the Globus account itself. So anyway, I lost and had to regenerate a new Globus account. That's why I'm bringing this up. Okay, Globus uses the concept of endpoints. You have permanent endpoints like NCSA Blue Waters, NCSA Nearline, which are different. Exceed, TAC, Stampede 2, for example. You can create temporary Globus endpoints using a Globus Connect Personal, which is just a thing that you download and you run. This is generally pretty painless. It's a little bit sensitive to super, super tight firewalling. So if you're way inside a university network and they're really persnickety about sockets, then sometimes you have to convince people to open those up a little bit. But if you want to transfer stuff to and from big machines from your laptop or from your university cluster, whatever, Globus Connect Personal is a great way to do it. So tools to not use for moving things. rsync especially. Now tar is great to use it in a job, but if you use it on the head nodes, it's going to bog things down. SCP, SFTP, they're fine for moving. If you're pulling down source code, if you're pulling down even a small data directory, like, I don't know, less than a few gigabytes or something. But login nodes are shared resources. When you use these commands, you are not using the 64 IE mover nodes. You are using resources that live on the login nodes. And the reason I made this as an abstract blob is because it's not necessarily one thing. It's data bandwidth from the login node. It is RCP calls from the login node. There are finite resources on the login node, and if you stack up, 6 SCPs all at once, it will start to soak those up, and then everybody's file system slows down. So basically, if you're starting one of these things, and then, that's taking a long time, I'm going to go get coffee, and then you go get coffee, and you come back 10 or 12 minutes later, and it's still running, that's a good time to decide, ooh, this is taking longer than I expected, I'm going to stop and put this in a job. So that's just a good rule of thumb. We will generally, we have things in place to kill these if they run very long, and they'll send you a nasty gram and email. But just don't. And this is going to be true at TAC, I'm sure, as well. Let's see. So, okay, that's data movement in Globus and stuff. Any questions on that before I go on? I'm almost done. Anyone? Okay. So if you're running jobs, now I'm going to have a brief diversion about running your actual jobs in Blue Waters. Read and write to Scratch when you're in jobs. That's just, Scratch is the big capable file system. It's got hundreds of OSTs as opposed to dozens. It's much more larger. The metadata server is much faster and can take a lot more load. Just very briefly about data access patterns. You can have, it's awesome if you can have your application open one file with one file pointer and then just spread the data out over MPI. That's awesome. Sometimes codes aren't architected that way. You can have one rank per file. That works to a certain point. That works to a few thousand ranks. If you get more than several thousand ranks, that starts to bog down even the Blue Waters Scratch file system. If every rank writes to a different place in the same file, that's okay. You have to manually manage how it does that. There are libraries that will help you do this, HDF, NetCDF, et cetera, which will help you basically put stuff within files and organize it. Just a quick comment. These are how you do file topology is something you really need to pay attention to when you start to scale up. So if you have a code that runs 2,000 ranks, there may be things you can get away with that you can't get away with if you go up to 50,000 ranks. So this is a question you will need to ask yourself. Sometimes there will be file locking or metadata saturation things that will happen when you start to scale your code up. So pay attention to that. It's questions to ask yourself. How many files is my code read and write? Is that topology appropriate for the systems, for the directories that I'm writing to? And have I looked at these questions again when I cranked my code up to a larger size? I mean, it's awesome. We love it when you scale your code up to be something bigger and parallel, and that's all fancy and exciting. But it's good to revisit these questions am I writing too many files all at once? Specific, okay, so last couple of slides. A very specific thing for if you're moving stuff from Blue Waters to, I should have said, Frontera. Both NCSA and TAC want you to be able to do this efficiently. We're all about doing scientific stuff. We know they are the big next customer, and we want you to be able to do this. There are ways that you do not have access to make such transfers work well, but you do not have access to them. To get that sort of help, if it's not working well, you have to ask. So if you are doing so, I'm very specifically talking to you and some other people in the room. If the thing you were trying to do does not seem to be working, send in a ticket and say, I am trying to transfer files from Blue Waters to this. My file magnitude is this. My file number is this. It doesn't seem to be working. What am I doing wrong? And people will be absolutely happy to say, you're turning this knob the wrong way. We can help you. If you do, try this and see if that works. If it doesn't, let us know, and we can start turning knobs for you, because we want you to be able to transfer your stuff and for you to be efficient. So, but you have to ask. Ask at least at one end, if not both, and make sure everybody's on the loop if you've got really, really big data collections to transfer. So ask, it's always helpful. No one will ever vote you off the island because you asked a question. We will say, absolutely, let's do it. Let's make it happen for you. Any questions about that specifically? And more generally, we're happy to help you. Send in tickets. We want you to be successful. We want you to do good stuff in computing.